Hi class, it's Miss Manual again, and we are going to talk about chemical bonding. Now, we've already gone over the periodic table and talked about valence shell electrons and how they bond. Atoms of different kinds bond with each other with those outer shell of electrons. It will be quick review for that, and also a simple way for us to learn how to put simple molecules together. So our standard that we're going to cover is the Chem Standard 1.1.2. It's matter, properties, and change. So we're going to talk about types of bonds and chemical formulas between atoms. So the objective for this class, and you will have to do this at the end of my talk, is to, given a periodic table of elements and writing materials, you will draw a Lewis structure of carbon and fluorine atoms and determine how they will bond together to form a simple compound. Now, it's up to you to decide which of those atoms is the central atom and which ones are the bonded atoms, and how many of the bonded atoms are going to be in that chemical formula. So we will go over this really quickly. So you will determine type of bond by location of atoms on a periodic table and predict chemical formulas or compounds using your Lewis dot structure. So quick review, periodic table. I have two different periodic tables here so that you can kind of get a glimpse of what kind of elements will go together, what kind of atoms will go together. So we know that metals and nonmetals, when they bond, they actually don't share electrons, they give or they take, and they form ionic compounds. What we're going to be looking at today are covalent compounds. So it will be the combination of nonmetals with nonmetals. And as you can see from this periodic table, it kind of gives you an idea of which ones are metals, which ones are nonmetals, and then the metalloids. And also the periodic table on the right will tell you the number of valence electrons. So it makes it a little bit easy for you. All right, so atomic structure. Let's go through atomic structure just a little bit, and I'm going to move myself down here. So if you have, remember this little ditty, if you have a valence of 8, that means it's feeling great. So all atoms want to have 8 on its outer shell. If you have a valence of 4 or less, it is going to bless, which means that it's going to give up some of its electrons or share those electrons. And if you have a valence of 4 or more, it is going to want to score, which means it is going to want to take electrons. All right, so a little bit of practice. If we take water, which we've learned about in a previous class, and we all love water, right? The first step is to write the Lewis structure, the dot diagram for hydrogen and oxygen. Now, oxygen, according to our periodic table, remember our periodic table of elements, has 6 valence electrons, and hydrogen has 1. So remember, if it has 4 or more, it's going to want to score. So oxygen is going to want to take some electrons, and hydrogen is going to want to give them away. Each oxygen atom has room to receive 2 electrons. Because it has 6, it's going to want 2 more. And hydrogen is going to want to give away the one that it has or share it. So you're going to decide which one is the central atom. The central atom in this case is the one that's going to take the electrons, which is oxygen. And hydrogen is going to be bonded to oxygen. So how many bonds will be created? Okay, like I said, oxygen is going to want to take 2. Hydrogen has 1 to give. So I'm trying to get my screening right. So oxygen wants 2, hydrogen only has 1. So you're going to have more than 1 hydrogen atom to give electrons away. So we'll see that in the next, and I will pull up a drawing pad so that you can see what this looks like. So if I do, and I will try to make myself go into the other part of the screen here. If I draw oxygen in blue, this is my oxygen, and my 6 valence electrons. Remember, when you're doing a Lewis dot diagram, it's going to have 8. So you're going to do it in ones before you pair them up. So 1, 2, 3, 4, 5, 6. Ah, there we go. Oxygen has 6 valence electrons. Now we have the other part of the equation, which is hydrogen. Hydrogen has the lonely 1. So we have one right here. And then we have another hydrogen atom, which also has 1. So in order for oxygen to have 8 in its valence orbital, it's going to share, and I will draw a bond here, it's going to share it with hydrogen, that first hydrogen, and it's going to share it with this hydrogen. And I can just go ahead and move that dot over a little bit. If I can do that very quickly. I'll move that guy over a little bit so you'll see oxygen is happy. It has 8. Hydrogen is happy because it gave away, or it's sharing its single electron, so it has a pair. So it is now happy as it can be. Now back, so the molecule here in this case is water. It's dihydrogen oxide. So now that you have a quick demonstration, I want you guys to do the same thing. I want you, given a periodic table of elements and writing materials, draw the Lewis structure of carbon and fluorine atoms and determine how they will bond together to form a simple compound, correctly noting the central atom and the number of position of each bonded atom around the central atom. And this should be easy peasy for you guys because I know you can do it.